All right. So for review for your test that is on Halloween, which is on Friday, um, here is a video recording of the review worksheet that you got on Wednesday, October 29th. It will be posted Wednesday. You'll have Thursday to watch it, Friday, and to use as review for requalifiers, whatnot. All right. So I'm going to zoom in a bit on the page because I can't read what it says. Okay. Questions 1 and 2, we are evaluating for the expression. We know that x equals 2, y equals 4. All that means is that wherever I see an x in my equation, I'm going to replace it with a 2. So that's my first step. Step 1, replace. So I'm going to put the 2 in place of the x's here. So I have a 2 to the 8, and I'm multiplying it by a 2 to the negative 5. And then the word evaluate is really just saying solve. What does it equal? What does it equal? So I'm going to get my trusty calculator friend out to help me out here. I'm going to type in what 2 to the 8 is. 2 to the 8. Notice that on my calculator screen here, that's what it should look like on yours, even though I pressed a different button because I have a different calculator. So 2 to the 8 is 256. And then I'm going to multiply that by whatever 2 to the negative 5th is. 2 up arrow 5. I want to make it negative. Again, your calculator, you would do 2 up arrow negative 5 if you're using my handheld calculators, which on the test you will, that's the only calculator you are allowed to use. All right, so that is a lovely decimal of 0.03125. So I substituted, I exponented it, and now I am going to multiply. What color should I use? We'll go back. Calculator. And notice on my calculator, I still have this decimal in here. I'm not going to clear it. Why? Because then I have to type it back in. I'm just going to say I'm going to multiply it by 256. And that whole thing just equals an 8. My answer is 8. That was one method. Another method I could have done is been like, hey, they have the same base. So I could take my exponents and add them. And that gives me a 2 to the 3. And then type in 2 to the 3 in my calculator. And that also gives me an 8. I don't care which way you get the answer, but it does say that you have to show work. So please show your work. No work equals no credit. Even if you say all of that equals 8, if I don't see what steps you took, it's going to be wrong. All right. Part B. Now we have y's. So my y is 4. So I'm going to replace that, each y with a 4. So I have 4 to the 7, and I'm going to divide that by 4 to the 5. Again, calculator. What is 4 to the 7 equal to? 16,384. So 16,384 divided by whatever 4 to the 5 is, 1,024. And then I'm going to do my division. So this one I do have to, because order matters with division. So 16,384 divided by 1,024, and I get 16. as my answer. Okay. Another way I could have gotten that has been like, oh, I'm dividing. So when I'm dividing powers that have the same base, my base is a 4, I can keep that base and subtract my exponents. 7 minus 5 is 2, and 4 to the 2 is equal to 16. Just like 2 to the 3 is equal to 8. Okay. Again, I don't care which work you show. You could show the work in blue. You can show the work in red. You just have to show work. Otherwise, you're not going to get credit. All right, question 2, we are writing an equivalent expression. Each should have a single positive exponent. So these are using your exponent properties. They will be listed on your test. They will be given to you. They are on anchor charts on this left and the right side of my room. So no, you do not have to memorize them, but yes, you do have to use them. All right, negative exponents. Well, that's just, if I don't like my exponent, if the exponent is negative where it is, I'm going to take the whole thing and move it down in the fraction. And because it moves down in the fraction, the exponent becomes positive, or because it switches spots in the fraction. So I have a z to the 3 in the bottom part of my fraction. Now there's nothing left in the top, but that 1 is going to pop up into the top part of my fraction. Okay. All right, for problem with the 6 to the 7 divided by 6 to the 12, very similar to what we just did up here with the 4s. I could subtract my exponents. I could also, there's nothing wrong that says I can't, like, we did this, right? We'll draw 7 6s. 6 7. Oh, that one was recorded. That's nice. And then 12 6s. 6 7. 8 10 11 12. Did I get all of them? 1 2 3. I did. Okay. So then for every 6 that I have in the numerator, I can cross 1 out in the denominator, keep on going until there are no 6s left on one of my levels. Oh, there's nothing left in the top. Or is there? There's always that imaginary 1. And then what do I have left in the denominator? 1 2 3 4 5 6s. So I have the fraction of 1 over 6 to the 5. How did that happen? Well, had I kept and just used my properties and subtracted my exponents, it's always the first exponent minus the second one. That would have given me 6 to the negative 5. And then what do we do with negative exponents? They switch spots in the fraction. Okay, so it doesn't matter which method you use. Both will give you the same outcome. 8 to the 5 to the 3. Okay, this would be saying like I have 3 parentheses. That's what the 3 says. And then inside each parenthesis, I have 5 eighths. 1 2 3 4 5. 1 2 3 4 5. 1 2 3 4 5. How many total 8s do I have? So what do I have? I have 8s. That's the base. How many? Well, there's 5, 10, 15 total. So my answer would be 8 to the 15. Using the exponent property, which is the power of the powers property, which is property number 3 on the anchor charts, it says we would multiply our exponents together. 5 times 3. Yeah, that's a 15. Okay. But again, if we need to write it out, we can write it out just like we did with the 6's over here. And for the last one, I have 12 x's, then I have 5 x's in the denominator and 0. I'm not going to write this one out. I'm just going to use my product of powers because I know all of my bases are the same. So all the bases are the same here. So I can keep the base and then take the exponents and add them. So 12 plus a -5 plus 0. And whatever that gives me is going to be my answer. So again, I keep my base. 12 plus -5 is 7. 7 plus 0 is 7. So my answer is x to the 7. Yep. All right. For question number 3, this is very similar to the question 2A, if I was to like call them A, B, and C's. A, B. This would be C and D. So problem number 3 is like question 2A, and that we're only using the negative exponent property. And I do have this written on the anchor charts. If we have a negative exponent and it's negative where it's at in the fraction, to make it positive, we just flip the location. And then, so that means that there's nothing in the bottom. So the 1, so we could leave it as that, 3 to the 5 all over 1. But if I have something over 1, isn't that just 3 to the 5? Okay, but either one of those would be correct. You don't have to do anything else. Standard form would be with the zeros, with your zeros. So we have a negative exponent. That means I want the zeros. I'm going to move my decimal point 7 spots because that's the number of my exponent. And it's negative. Negative numbers on a number line are to the left. So I'm going to take my decimal point and I'm going to move it 7 spots. There's 1, there's 2, 3, 4, 5, 6, 7. Decimal point gets moved. Any spot that does not have a number is going to get filled in with a 0. Okay, but I'm not going to leave it like that because that's really hard to read as somebody who has to grade over 100 of these papers. So 3, 4, 5. The 2 would be a 6. The 9 would have been the 7th spot. 9, 8. So notice that my decimal point was originally here and it moved now in front. I'm not going to leave my decimal point between the 2 9s. I'm going to get rid of it. This is my answer. Standard form means that we have all of the zeros. Okay, you could have also just done this multiplication in a calculator and then written the answer. All right, let's look at 4B. Exponent on the 10 is a 5, so now we're going to move the decimal, the number 5 spots. And because the 5 is positive, we're going to go to the right. So moving my decimal point. Behind the 3 is 1 spot. Behind the 2 is 2 spots. 3, 4, 5. And again, any spot that doesn't have a number, a digit in it, I'm going to fill with a 0. So -5, that didn't take up a spot. 3, 2, and then I have 3 zeros. And my decimal point is at the very end. So it started off between the -5 and the 3, and I moved it 5 spots to the left, and now it's after the third 0. But again, I'm not going to leave my answer there. I'm going to get rid of it. And if you want to, you could put in your place value commas, up to you. Honestly, I count zeros and I look for where the decimal point is. So in standard form, the decimal point has to be at either the very beginning of the number. Granted, you could have a 0 in front of it for 4a. You don't have to. Or it's at the very end of the number. It should not be anywhere in between. Question number 5. Now we're going into scientific notation. So that means we're going to have something, single number, digit, and then, yeah, we could have more numbers, and then times 10 to an exponent. That is what scientific notation should look like. So first thing we do is we locate our decimal point. If I don't see it, it's at the end. And I know there can only be one number in front of it. So I'm going to move it between the 4 and the 5. So 4.52. I don't have to write the zeros behind the 2 because there's no other digit. If you wanted to, you can. And then we have our times 10. The exponent is how many spaces it moved. 1, 2, 3, 4, 5, 6. It moved 7 spots to the right. So because it moved to the, it moved 7 spots to the left. But my zeros are on the right-hand side. Positive numbers are on the right-hand side of a number line. So my exponent is 0 or is positive. 4.52 times 10 to the 7. And shocking, you can check that. 4.52 times 10, raise that to the 7. And is that what I started with? Yeah, look, I have 5 zeros behind my 2. 5 zeros behind my 2. So I can check it using the calculator. What? Crazy. Crazy. Okay, 5b. I'm going to take my decimal point. I see it, and I want to move it so that it is behind one number. This is a negative exponent because the zeros are in front. So what do I have? 2.05 times 10. How many spaces did the decimal point move? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spots. All right, I'm going to pause because it is time for first period. All right, problem number 6, multiplying or dividing. So looking at this question, we are multiplying because I don't see anything between the two numbers. So I'm going to go ahead and multiply the numbers in scientific notation that are in the same part of the scientific notation. So I'm going to take the 5.4 and multiply it with the 3.8. The times 10, it's going to stay at times 10. And then when you're multiplying exponents and they have the same base, so both of these have the same base, the exponents themselves, the 7 and the 2, are going to be added. So 5.4 times 3.8 0.4 times 3.8 is 20.52. Again, we're keeping the times 10, a times 10. And then 7 plus 2 is 9. But since these are given to us in scientific notation, my answer should be in scientific notation. So this needs to be in scientific notation, and it's not. How do I know? Well, the number in front of the decimal point is bigger than 10. And that's not allowed. So again, this right here, 20.52, that's bigger than 10. And we can't have that. So I'm going to move the decimal point one spot over. So it becomes 2.052 times 10. And then instead of having, because I moved the decimal point, I have to change the exponent. I moved it. So I'm going to add. And 9 plus 1 is 10. Okay, and if you don't believe, so we had that number 20.52 times 10 to the 9. 0.52 times 10 raised to the 9. Looks like that. So six, 9. And then let's make sure that 2.052 times 10 to the 10 gives me the same thing. It's the same thing. 20, 520, 000, 000. They're the same. But this one is in scientific notation, the 2.052, because in front of our decimal point is a digit, a single digit. We're not allowed to have two digits in front of our scientific notation. And this was the same number. So because those were the same, this one's in scientific notation, that's my answer. Number 7, very much like number 6, we're multiplying again. How do I know? Well, I don't see anything between my two scientific notations. So I'm going to take the 6.18 and the 7.3 and multiply. 6.18 is going to get multiplied by 7.3. Bring my calculator up for that. 6.18 times 7.3, and I get 45.114. You will always and forever have a times 10. It's times 10. And then for the exponents, we're going to add those suckers. They're going to be added. So -3 plus a -5. And if I'm struggle with my integer addition, it's okay. Calculators can do that. So -3 plus -5. And my keystrokes, again, for this calculator is different than the calculators that you have access to in the classroom. You would actually type in the negative before the number. I can't do that. Okay, but -3 plus -5 is a -8. And then again, I need my answer in scientific notation, but I have two numbers in front of my decimal point, and that is not allowed. So we are going to move the decimal point one spot over to be a 4.5114 times 10. And then because we moved the decimal point one spot to the left, we are going to add a 1. So -8 plus 1. Oh, man. Okay, so 8 negative plus 1 equals a -7. That's going to be my answer. And again, I could check to make sure that I had everything, that the two were correct or equal, but I believe in myself. Okay, for number 8, we're dividing both of these. It's just broken up into an A and a B. So very similar to the multiplication, we're going to divide the numbers that are in the like parts. So the multiplication kind of splits it up, just gives us a multiplication. So we're going to take the 1.2 and divide it by 4. And then for the powers of 10, we are going to use the quotient of powers property, which is property number 4. And that says we keep the base and subtract the exponents top 1 minus bottom 1. Okay, cool. So let's see what we get. 1.2 divided by 4 is a 0.3 times 10. 8 minus 3 is a 5. Are we in scientific notation? To be in scientific notation, the number in front of our multiplication has to be between 1 and 10. 0.3 is smaller than 1. So that doesn't work. So we have to move the decimal point 1 spot backwards. And if we're going backwards, we are going to subtract 1 in the exponent. So that would give us a 3.0, or just 3 times 10 to the 4. Scientific notation, 5 minus 1 is 4. We're here. We're going to do our division. -6.8 divided by 3.4 times 10, -3 minus -6, top minus bottom for exponents. All right, so 6.8, make that negative, divided by 3.4. We get a -2. That's nice. Oops. So all of this is equal to -2 times 10. Not the best with subtracting, let alone subtracting negative. So -3 minus -6 is a +3. That's a little weird, but that's what the calculator told me. The number in front of the decimal point is between 1 and 10. Yes, it's negative. We're just going to go with it. But the number itself is between 1 and 10. And then we have our power. So we're done. We didn't have to do any movements. All right. That was it. So your test has a total of 5 questions. But if we look at like the different parts, like the part A and the part B, there's 10 things that you are doing on the test. You do not have a division problem, so that was just taken away. There's only one of the multiplication problems. You do have writing in scientific notation, you have writing in standard form, and you have all of this. So that is what your test will look like. Shorter than this review. I wish you luck. Happy Halloween. All those good fun things.